You are a king of an empire. You have a servant working in your palace. He works all the 7 days and you only pay him in the form of gold bar. You must pay the worker for his work every day at the end of the day. If you are only able to make 2 breaks in the gold bar, how will you pay the servant if the servant works for the equal time every day and thus equal amount must be paid at the end of the day? If you are thinking of how to cut in such a way that you are able to make 7 equal pieces, you are thinking in the wrong direction. You should give more stress on how to make the transactions with the worker. So the trick is not to try and how to cut in such a way to make 7 equal pieces, but rather to make transactions with the worker. Make 2 cuts on the gold bar such that you have the following sizes of bars. Bar A should be 1/7 of the bar B should be 2/7 of the bar C should be 4/7 of the bar. Let's check whether it is going to work. When the day 1 ends, give bar A to the worker. Here you remain with bar B and bar C. Worker possess bar A. When the day 2 ends, give bar B to the worker and take the bar A back. Here you remain with bar A and bar C. Worker possess bar B. When the day 3 ends, give bar A to the worker. You remain with bar C. Worker possess bar A and bar B. When the day 4 ends, give bar C to the worker and take back bar A and bar B. Here you remain with bar A and bar B. Worker possess bar C. When the day 5 ends, give bar A to the worker. You remain with bar B. Worker possess bar A and bar C. When the day 6 ends, give bar B to the worker and take back bar A. Here you remain with bar A. Worker possess bar B and bar C. When the day 7 ends, give bar A to the worker. Here you remain with no bar. Worker possess bar A, bar B and bar C. Thus by the end of 7 days, you have taken care of everything. This is a clever logical interview puzzle. 99% of the people fails to answer this. If you are lucky, you can get the same question and you can answer in less than a minute. At a party, everyone shook hands with everybody else. There were 66 handshakes. How many people were at the party? This is one of the most frequently asked interview puzzles. Feel free to pause the video and give it a try before checking the solution. I will be back in 10 seconds. Let me explain the solution now. Let's suppose that there are n number of people in the party. The first person will shake hand with n minus 1 people. The second person will shake hand with n minus 2 people. The third person will shake hand with n minus 3 people. In this way, n minus 1th person, that is, last but one person, will shake hand with n minus 1, which is equal to 1 person, that is the last person. Now add all the number of handshakes, n minus 1 plus n minus 2 plus n minus 3 plus so on till 3 plus 2 plus 1. If you observe this particular series carefully, this is nothing but the sum of n natural numbers, but only difference is here the n is n minus 1. We know that the sum of natural numbers formula is obtained by using the arithmetic progression formula where the common difference between the preceding and succeeding numbers is 1. Natural numbers are also called counting numbers, start from the number 1 until infinity, such as 1, 2, 3, 4, 5, 6, 7 and so on. Sum of n natural numbers formula is represented like this: n times n plus 1 over 2, where n is the last number. In this case, we know that n is n minus 1 Hence formula becomes n minus 1 times n minus 1 plus 1 over 2. After simplification, formula becomes n times n minus 1 over 2. Also, we know that in the puzzle, the total handshakes given are 66. Hence, the equation becomes n times n minus 1 over 2, which is equal to 66. After simplification, it becomes n times n minus 1 equals 132. Further simplification results in n square minus n minus 132, which is equal to 0. This is nothing but the quadratic equation. After solving quadratic equation, we get n minus 12 or n plus 11 equals 0. Here, either n equals 12 or n equals minus 11. Since number of people can't be negative, n will be 12. Hence, there are 12 people in the party. By following these simple steps, we can solve this puzzle in less than 30 seconds. We are given a series of numbers which contains integers from 1 to 50, including both 1 and 50. However, the numbers are in a jumbled form, that is, they are not arranged in increasing or decreasing order, and there is one integer missing. You have to identify the missing integer logically. Feel free to pause the video and give it a try before checking the solution. Once done, continue watching the video for the right answer. Let me explain the solution now. As per the puzzle, there are series of numbers which are given and it contains integers from 1 to 50 and which includes both 1 and 50. However, the numbers are in a jumbled form and there is one integer missing. Our task is to identify the missing integer logically. Okay, we know that the sum of all the numbers from 1 to n can be calculated by using the formula n times n plus 1 over 2, where n is the last number in the series. Remember, this formula is applicable for only positive natural numbers. Let's understand this equation with simple example. Let's consider a series with 5 numbers 1, 2, 3, 4, 5. We can use the equation to find the sum of these numbers. Here the last number in the series is 5, hence n is 5. Hence this will result in 5 times 5 plus 1 over 2, which is equal to 15. Similarly, we will try for 50 numbers and hence n becomes 50. Therefore, sum of all the numbers from 1 to 50 is 50 times 50 plus 1 over 2. Here n is 50. And after simplifying, and we get 50 times 51 over 2. And further simplification, we get the value 1275. Hence, sum of all numbers from 1 to 50 is 1275. Therefore, all we need to do is to sum all the integer present in the given series and subtract the sum from 1 to 75. The difference between 1 to 75 and this sum would give us the missing integer, because 1275 is the sum of natural numbers from 1 to 50 and this number is sum of natural numbers from 1 to 50 without including missing number. Hence, subtracting the sum of given series from 1275 will fetch the missing number. By following these simple steps, we can find the solution for this particular puzzle in less than a minute. There are 3 keys that open locks of 3 different gates. In how many attempts you can figure out the key for each gate? This is one of the most interesting logical puzzles asked during interview. Feel free to pause the video and give it a try before checking the solution. Once done, continue watching the video for the right answer. Let me explain the solution now. There are 2 interpretations to this puzzle.
first interpretation is to identify the key for each gate and opening it. Other one is just to identify the key associated with the gate. According to first interpretation, that is to identify the key for each gate and opening it. Assuming that it is always the last key that works, the first lock will take 3 attempts, having eliminated 1 lock per key. The next takes 2 attempts, leaving 1 attempt for the last lock. Hence 3 plus 2 plus 1, which is equal to 6. Hence, to match all the keys to all the locks, the maximum number of tries is 6. The minimum is 3. The formula is 3 factorial, or 3 times 2 times 1, or 6. The first lock takes at most 3 tries. The second lock 2 tries, as 1 key was eliminated. The last lock takes 1 try, as only 1 key is left. Hence, the best performance in 3 attempts for 3 gates, getting right in the first attempts for all of the 3 gates, and for the worst performance in 6 attempts for 3 gates, getting right in the third attempt for the first gate, getting right in the second attempt for the second gate, and getting right in the first attempt for the third gate. Let's solve the problem for second interpretation, that is just to identify the key associated with the gate. Let us take one lock at a time. Now for one lock, we have 3 keys, but if 2 keys does not open it, it becomes obvious that third will do so. So maximum attempt for lock 1 is 2. Similarly, we have 2 keys now for the second lock, but if one does not work, we know that other would do so. Hence maximum attempt for lock 2 is 1. And for lock 3, we do not need any attempt because there is only 1 key left, which would be the right key. So maximum attempts in this particular interpretation will be 3. Hence, for the first interpretation, that is to identify the key for each gate and opening it, the answer is 6. And for the second interpretation, that is just to identify the key associated with the gate, the answer is 3.
We have to divide a square into 5 parts such that 4 parts among them are equal. The condition is that even once the pen does not get up. In simple words, solution to this puzzle must be achieved without lifting pen. Let me explain the solution now. We can solve this puzzle like this. We have to draw an inscribed circle within the square. In this way, all corners of the square are equal and square will be divided into 5 parts. The interesting part of the puzzle is, even if we draw a circle inside square, then we do not need to lift the pen. As we can see here, square is divided into 5 parts, part 1, part 2, part 3, part 4, part 5. And part 1, part 2, part 3, part 4 are equal. Thus, by drawing inscribed circle within square, we can divide a square into 5 parts such that 4 parts among them are equal. This is one such question frequently asked in interview. Do prepare for this.